All right, algebra classes. We're going to work on our 10.5 samples now, and there actually will be one sample split into three parts, and sample part 1A, part B, and part C. So let's see what we're up to. So we are asked to make a box and whiskers plot of the data, include and label the 5 data points used to create your plot. Show your work. And then for part B, calculate the interquartile range, known as IQR. Finally, identify any outliers. Show your work. So on each one of these steps, we need to show how we are getting our answers. So here's our data. We are told the price in dollars of 14 books that were found on Amazon on May 20th, 2020. So the prices are listed below right here for you. And there are yellow dots above those numbers. That's not what was given to you originally. Originally it was just the numbers that were written in black. And they're all mixed up. So the first price of a book was $62 that we ran into, and then $54 and so forth. Our first task to draw the box and whiskers plot to display this data is to write all of these numbers in order least to greatest. That's what the yellow dots, of course, are all about. If you want to go ahead and use a slash mark as you write these down in smallest to biggest, that would be fine as well, but somehow keep track so that you don't forget any numbers and so that no numbers are written down more than once that are in the list only once. All right, so here's my list from smallest to biggest. 3 was the cheapest book and $70 was the most expensive book. So I count and I find out I have 14 book prices altogether. That's an even number. So to start making my box and whiskers plot, I'm going to need to split my numbers that are ordered least to greatest into 4 distinct parts. The first thing I'm going to do is I'm going to split that list into 2 separate boxes. If there's an even number of values in your data, then those boxes will touch. Now in this case, since there's 14 pieces of data, I'll have 7 values in my lower box and 7 values in my higher box. If there's an odd number of numbers in your list, you'll still have 2 boxes, but there will be 1 number left in the middle. So in this case, there is no number left in the middle. That number in the middle, of course, would be the median. So we have to figure out what the median is for this list. To do that, we take these 2 numbers where the boxes touch each other and pull those numbers out. We will average them, find the mean. In other words, find the number that is smack dab in the middle of these. And if you think about it, that would have to be 54.5. But here's the technical way to find that answer, 54 plus 55 divided by 2. If it's obvious what that answer is going to be, then you just write it down. Our median is 54.5. That's the number exactly in between these 2 values, which are the middle numbers in the list. Again, if you have an odd number of numbers in your list, the boxes will not touch. There will be 1 number in between the 2 boxes that don't touch in a list of odd numbers, and then that would be the median. All right, we need our lower and our upper quartiles, so we go in each of these boxes separately. We find the number that is in the middle of that list. If there is an odd number of numbers in this box, then the lower quartile will be that 1 number exactly in the middle. If there's an even number of numbers in that lower box, then you would find the 2 numbers in the middle and you would average them, find their mean. Here in our upper box, we have, again, 7 values, so our upper quartile will be the number exactly in the middle. If there happens to be 2 numbers exactly in the middle, say there were an even number of numbers in that box, then you would find the mean of those 2 middle numbers. So in this case, our lower and upper quartile, there's no further work to do. We just pull them out, and there they are. So this is showing my work for how I'm setting up for my box and whiskers plot. Now I'm going to actually draw my box and whiskers plot, including my number line that's going to guide how big or how small to draw my whiskers and my box. So I'm noticing that my smallest value is 3, my biggest value is 78, so I'm going to go ahead and mark off my number line from 0 to 80 in intervals of 10. So you do not have to use intervals of 10. You can use any intervals that are constant that will work for the data that you're given. Maybe you're going by 5s, maybe you're going by 1s, maybe you're going by hundreds. Depends on your smallest and your biggest value and what size of intervals you would want in between to easily mark off all of the lower quartile, median, and upper quartile. All right, so I have my number line to guide what I'm doing. Now I pull off my least value, 3. The left whisker will spread out to 3. My lower quartile is 44. It's the bottom of the box. My median is 54.5. It's the middle of my box. My upper quartile is 63. It's the top of the box. And my Right-hand whisker will spread out to 78. That's my greatest value. These data values must be labeled 3, 44, 54.5, 63, 78. Without those data values, it's pretty tough to interpret your box and whiskers plot. So this is part of what must show on your box and whiskers plot, those 5 data points. And of course, this needs to be drawn correctly. So you do need to have that number line guiding how long to make the whisker, how wide to make the box, how long to make the whisker. Okay, so that's our box and whiskers plot. And we can see that the middle 50% of the data, because in the box, that's the middle 50% of the data, there isn't a lot of variability between the lowest priced and the highest priced book, 44 to 63. There does seem to be a lot of variability in the bottom quarter of the data, from 3 all the way to 44 is how far it spreads out. The top quarter of the data, that's the top whisker here, there isn't a lot of variability from 63 to 78. So remember, our box and whiskers plot does divide our data into 4 groups: the lower fourth of the data, the middle 50% of the data, and the top quarter of the data. So it's easy to see at a glance what's happening with our data. Does it clump together? Does it spread out? If it does clump or spread out, where? And so forth. All right. Part B, find the IQR. That's the interquartile range. That's the length of the box, your middle 50% of your data. How does it spread out? Well, you find the difference between the upper quartile and the lower quartile. So 63 minus 44, and that's 19. So the middle 50% of the data spreads out $19 worth. So that's the information we get from the IQR. And sometimes that interquartile range gives you a little bit better idea of what's happening with the data, because sometimes in the lower quarter and the top quarter, there's some data values that are much further away than what is typical. Not that it's bad data, but we're looking at what's typical. All right, last step, outliers. Remember, an outlier is a data value that is significantly far away from your quartiles, from your upper and your lower quartiles. It might be data that is inaccurate, it might be data that is accurate, and there might be a reason for why you have some data that's far away from your median and from your quartiles. Nonetheless, outliers are going to be values that are significantly different. They're very far away from either one of these quartiles. Well, we have to look to see, are there any possible outliers? To do that, we look at the whiskers and how long they are. If you have a whisker that appears to be significantly longer than the length of the box, you're going to suspect there might be an outlier. Well, in this case, this whisker here, compared to the length of this box, doesn't look like it's significantly different. It looks about the same. So we would not suspect there's an outlier up here. But down here, this whisker is way longer than the box, so there might be an outlier someplace down here. So let's look at our least value and see if that is an outlier. Is it significantly far away from all of the other data values here? So none above the upper quartile of 63 because the whisker is shorter than the box. Maybe 3 is an outlier because the whisker looks significantly longer than the box. So we're going to check if 3 is an outlier. So that's my thinking. All right, so to check, here's what I do. I take my least or my greatest value, in this case my least value, and I ask if it's the least value, is it less than? If we were looking at a data value that is above the box, we would be asking greater than. Okay, so if we suspect the least value is an outlier, we're going to use our less than. It's 3 less than, and then we're going to do the math for that. If we suspected there was an outlier up here, we would put that greatest value here, and we would ask, is it greater than? Okay, so we have to know which direction we're going to decide if we're less than or greater than. Suspecting an outlier greater than a value in the box, we would put a greater than. If we are finding an outlier potentially that is the least value, we're putting a less than. Okay, how do we figure it out? Well, we go to the closest quartile, that's 44, and we ask, is 44 minus the interquartile range, 19 in this case, times 1.5, is the difference of the lower quartile, and 1.5 times the interquartile range is 3 less than that quantity, because if it is, we'll consider it an outlier. Now, again, because this is an outlier potentially that is a least value, we're using less than and we're subtracting. If this were a data value that we would suspect is an outlier above the upper quartile, then we would put greater than and we'd be adding here because we want to see if an outlier possibly up here, is greater than the interquartile range times 1.5 plus the upper quartile. So for the smallest possible outlier, less than, minus. If you suspect an outlier is above the box, you would be putting greater than and plus. All right, so let's work out for this possible outlier. Is 3 less than 44 minus 19 times 1.5? 19 times 1.5 is 28.5. Subtracting 44 minus 28.5 gives me 15.5. So 3 is less than the difference of the lower quartile minus interquartile range times 1.5. It's significantly far away from all the other data values. Because this is a true statement, 3 is an outlier. All right, so that finishes our samples. So it's time for you to move on to the quiz. You'll be working the same type of problem in the quiz, finding 3 different answers, box and whiskers plot, interquartile range, and any possible outliers. All right, I'll see you next time.